Hello and welcome to the solutions to the Year 10 Maths Pythagoras Theorem revision sheet. In this, I plan to go through each of the questions and show you how I would be working out each of the solutions. So question 1. If we look at this, we want to find out the length of the hypotenuse in the triangle. So the first thing we need to do is label our triangle. So opposite the right angle is going to be C, and our other two sides are going to be A, and they're going to be B. So that's our, now we've got our figure, and we've got our facts on that figure. Next, we need to write our formula. So Pythagoras A squared plus B squared equals C squared. So that is now our formula. We're going to do a substitution now. So A is 7, so it's 7 squared plus 5 squared equals C squared, because there's nothing there. And now we're into our find it section. And we work through our find it. So 7 squared is 49, 5 squared is 25, that's equals C squared. That's going to give us 74 equals C squared, so C is going to be equal to square root 74 centimetres. So now we're into our fix it section. So it's asked us in a sentence, so we need to answer in a sentence. So the hypotenuse is square root 74 centimetres long. And that's what we call our fix it. Got my 74 here. That is question 1. Question 2. Ask the radio mast is a support wire tied 8.1 metres above the ground level. The other end is tied to a peg at the ground. Find in one decimal place the distance from the peg to the base of the mast. So again, we've got our diagram there. You could redraw this without all the extra bits of information, but I'm just going to use the diagram that's there. So we want to find x, this distance from the peg to the ground. So now we've got a right angle triangle. So we label our right angle triangle. The side opposite the right angle is C. The other two sides are A and B. So now we've got our figure, we've got our facts. So again, we're going to write our formula. So writing our formula down, we've got A squared plus B squared equals C squared. And now we're going to substitute in. So A is X, B is 8.1, that's going to be all squared, equals 10 squared. So that is our, now we're into our find it. So into our find it section, so it's going to be X squared plus now 8.1 times by 8.1 is 71.28. That's going to equal to 100. Opposite of adding, 71.28 is taking away. So 100 takes 71.28. So x squared equals 28.72. So x equals square root 28.72. And we're asked to find it to one decimal place, so we plug that into our calculator and we get 5.4 meters. Again, this is a worded question, so we need to answer it with words. So the peg is 5.4 meters out from the mast. Again, this is our fix it section. That's question 2. Question 3. Again, we've just got a Pythagoras triangle that we need to label. First thing we do, opposite the right angle is C. The two sides there are A and B. So now I've got my figure, and I've got my facts. Next, I'm going to write my formula, a squared plus b squared equals c squared. So I've got our formula. The first question I usually get asked in this one, oh, it's got so many x's, how am I going to do this question? As you can see here, I've now got my 3 marks without even having a look at where the x's and so forth are. So the first part of my next step is to just put in the data. So I've got x squared plus 4 squared equals 3x 4 squared. And so that's going to be started our find it section. So it's going to be x squared. 4 gives us 16, equals 3 squared is 9, it's going to be x squared. So you can see here we've only just started dealing with the actual x's. So at the moment I want to get the x's on the one side, so the opposite of adding x squared is going to be taking x squared, so 9x take x squared. So the way I talk about that is being 9 apples take away an apple, so we're left with 8 apples. So the opposite of timesing by 8 is going to be dividing by 8. So x squared equals 2, so x equals square root 2. And the last thing we need to do is put our units in meters, and that becomes our fix-it. Because we need to make sure we have our units in there. So that is question 3. Question 4. We're told we need to find x, and we've got this isosceles triangle. So one of the things that I know about isosceles triangle is those two base lengths are equal. So that means they're going to both be half 12, which happens to be 6. And so this one here is going to be the first one where I'm going to draw a new diagram. Mainly because I want a diagram that shows me the information without all the confusing bits. So that side there is going to be x, that's going to be 6.8 meters. And so the base now is only half the 12, so that's going to be 6 meters. And again, I go through and label this triangle, so opposite the right angle is C, and my other side, 2 sides are going to be A and B. Again, we're just dealing with Pythagoras, so a squared plus b squared equals c squared. And so now we have got our figure, and our facts, going on our figure, and we've got our formula. So we're going to substitute in now. So a is x squared plus b, which is 6 squared, equals c, which is 6.8 squared. So it's x squared plus 36 equals 46.24. So x squared, sorry, so an opposite of adding 36, you're going to be taking, so x squared equals 46.24, take 36, so x squared equals 10.24, so x is going to be square root 10.24. And when we look up the top, we see that it's meters, and all it has to do is find x. So I found x, so that's my fix-it section, and I'll put in here when I find it. Question 5, we're asked to work out which one of these is a right angle triangle. So this one here, we're given all the information. So what we need to do is work out the left-hand side of the equation and the right-hand side of the equation. And so on the left-hand side, we're going to have a squared plus b squared, and the right-hand side, we're going to have c squared. Before we can do anything, though, we need to understand where a, b, and c are on our diagram. C is always going to be the longest side. I generally start with A being the shortest and B being the middle one, just so that we know there's a pattern to do. So in this case, A squared, so it's going to be 3 squared plus 5 squared, so it's going to be 9 plus 25, so equals 34. On the other side, that's going to be 6 squared, so it's going to equal 36. And so now we can say down the bottom, left-hand side It's not equal right hand side. So 34 doesn't equal 36. So therefore, not right angle triangle. Next one, left hand side, right hand side. So again, left hand side is a squared plus b squared, and right hand side is c squared. So look at our triangle and work out which is the longest length. Square root of 14 is going to be somewhere between square root 9 and square root 16, so it's somewhere between 3 and 4, so that's going to be the longest side. If you're not quite sure, put it in the calculator, find out its exact value, and see how it compares. I know square root 5 is going to be the least, because that's between square root 4 and square root 9, so it's going to be somewhere in 2. So 3 is going to be the middle number. So it's going to be equal to here, square root 5 squared plus 3 squared. So squaring a square root is just the number underneath the square root. So plus 3 squared is 9. That's going to give me the answer there of 14. On the other side, I've got square root 14 squared. So again, that's just going to be the number underneath the square root. So here we've got left hand side equals right hand side. So the left hand side equals the right hand side. If the left hand side is equal to the right hand side, therefore we've got a right angle triangle. The third one of these, we've got left hand side, right hand side, and a squared plus b squared is my left hand side, and right hand side is c squared. Again, I'm going to have a look at my diagram. Square root 201 is between 14 and 15. That's 225, so that's going to be my C. That's going to be my A. That's going to be my B. So again, substituting in 9 squared plus 11 squared. So that's going to be 81 plus 121 equals 202. C squared is going to be square root 201 squared, so equals 201. So again, my left hand side does not equal right hand side, therefore not right angle triangle. So that is question 5. Question 6. A rhombus has a diagonal length of 12 centimeters and 16 centimeters. Find the perimeter of the rhombus. So we need to understand the rhombus first. So a rhombus, we draw a rhombus. First thing we know about a rhombus is each of the sides are of the same length. If we draw our diagonals in, we call that one 12 centimeters. And we draw our other diagonal in, and that one there is 16 centimeters. The thing we know about our rhombus is the two diagonals bisect each other, so they become the same length, and they intersect each other at 90 degrees. So if I write this, if I redraw this diagram now, so I've only got its information. So I'm only going to draw the right-hand quarter. So at the moment, what I don't know is I don't know the value right here. That's going to be x. I don't know that. I want to find that, then I can work out the perimeter. So this side up the top, I know that 16 is the full length, so half of 16 is going to give me 8 centimeters. And down the bottom is half of 12 is going to give me 6 centimeters. So now I've got a right angle triangle. So labeling a right angle triangle, I've got C, and then my sides, either side of the right angle are going to be A and B. So that's now giving me my figure. In this case, I've had to draw 2, and I've got my facts. Why have I drawn a second diagram? Because my facts now are indisputable on the second diagram. It's a lot easier to read. So A squared plus B squared equals C squared. So that's now my formula. And we start working through with that. So A, 8 squared, plus B, which is 6 squared, equals x squared. So 64 plus 36 equals x squared. So 100 equals x squared. X equals square root 100. So x equals 10 meters. So there's my find it. And there's the beginning of my fix it. So I look back at my question. Did I need to find the length of one side? No. I needed to find my perimeter. So I need to reset up a new formula. So perimeter equals 4 times by x, with the x being the length of the side. So we're doing a new formula here. So into that, we're going to plug our values. So equals 4 times by 10, so equals 40 centimeters. So here again, we're going to have our find it. And we've got our answer with a sentence. The perimeter of the rhombus is 40 centimeters. Again, there's our fix it. So sometimes, yes, you need to repeat the process multiple times for a question, only because the question, you just have to solve for two parts of the question. The first part was to work out what the length of the side was, and the second part was to then work out what the perimeter was. So Pythagorean triplets, we're going to follow these through with the same way that we worked out whether it's right angle. So we're going to have left-hand side, we're going to have right-hand side. But the way Pythagorean triplets are written is A, B, C. So they're always written in the form A, B, C. So A should be the first one, which is the smallest one. So on the left-hand side, A squared plus B squared. On the right-hand side, we're going to have C squared. So if we now substitute in, A is 1, plus B is 2 squared, so it's going to be 1 plus 4, so it's going to be 5. Right-hand side is going to be the square root 5 squared, so equals 5. So here we have left-hand side equals right-hand side, therefore pythag. So again, for the second one, left-hand side, right-hand side. We can write our formula in. A squared plus B squared is the left-hand side, C squared is the right-hand side. Having a look at our data there, A, B, C, because it's A, B, C, written in the order, the numbers are there. So it's going to be equal to 3 squared plus 5 squared. So it's going to be 9 plus 25. So equals 34. On the right-hand side, that's going to be equal to 6 squared equals 36. So again, we have left-hand side does not equal right-hand side, therefore not pythag triple. Next question. Let's go through again. Oh, we have a look at our data, and we notice here that we've got a negative number. So for pythag triple, need positive integers. Need positive integers. So therefore, not pythag triple. Because we've got a negative number in there, this one here automatically doesn't become a Pythagorean triplet. So last one, splitting up into two bits, left-hand side, right-hand side. A squared plus B squared is left-hand side, C squared is the right-hand side. Labelling them, A, B, C. So 20 squared plus 21 squared, that was 400 plus 441. So it's going to be 8 841. Right hand side is equal to 29 squared, so it's going to be 841. And we're looking at those, left hand side equals right hand side, so therefore pythag equal. So as you can see there, question 7 and question 5 we're working out in the same way. Obviously we're just looking for a slightly different ending point. Question 9, we need to go through and, so question 8, wrong one. Question 8, we need to look at this with a diagram. So first thing I'm going to do is on the diagram, I'm going to put north. And so my boat, first of all, travels 8 kilometres east. So I'm going to do 8 kilometres east. There we go, 8 kilometres east. Then that boat decides to travel 5 kilometres north. So 5 kilometres, about there on my diagram. 5 kilometres north. And finally it decides to travel 2 kilometres. 2 kilometres east. That's 2 kilometres. And we're asked to find how far away he is from the starting point. So if I do that, I've now got my right angle triangle, I've got my unknown. So I've got a lot of information on there, so what I want to do is redraw just my right angle triangle. And so on that right angle triangle, we know that this one here is 5 kilometres because that hasn't changed. The base here, this bit down the bottom, we need to have a look at our diagram. So we've got 8 kilometres and we come back 2 kilometres. So 8 take 2 is going to give us 6 kilometres. And the last bit there, we've got x. So we want to find that distance. So again, we label our diagram. So it's going to be C, and A and B are going to be either side of the right angle. So again, we've got our figure, and we've got our facts. I've got facts written in such a way that we can just read on. So A squared plus B squared equals C squared. So there's our formula now. And so now we can substitute in. A is going to be 5, B is going to be 6, C is x squared. So that's 25 plus 36 equals x squared. So that's going to be 61 equals x squared. So x equals square root 61. And it's going to be kilometres. But so that's now a find it section done. That's our find it section done, and we need to then answer it. It's asked in the sentence, so we need to answer it in the sentence. So the boat is square root 61 kilometres from its starting point. And that's how I fix it. Some people will be asking me, why have I left it as a third or a square root? Because that's the most accurate. You don't have to simplify it out any further than that. If you want to put in your calculator, 1 or 2 decimal places is what you need to go to. So question 9, ABCD is a rectangle inscribed in a circle. To find the radius of the circle. So one of the things I can draw straight away on this diagram is my diagonal across here. My diagonal I know goes through the centre of the circle. So that means my diagonal is going to be 2 times the radius. Or it's going to be the diameter. But the key bit of the question here is find the radius. So I'm going to write my diagonal in terms of radii, so that then when I come up the answer with r equals, I know that's going to be the radius. The next thing I'm going to do is actually draw that diagram without all the other bits and pieces. So I know that that's 10 centimetres, that's 8 centimetres, that's a right angle, and that's going to be 2r. We know that the corner of a rectangle is a right angle. So there's my figure redrawn. On my figure, I just need to add a little bit of information because I need to work out what my A, B, and C are. So that's going to be C, that's going to be A, that's going to be B. Again, doesn't matter which way you do A and B, just as long as they're next to the right angle. So A squared plus B squared equals C squared. So now I've got my figure. On my figure, I've got my facts. And up here now, I've got my formula. Substitute in. So A is going to be 10 squared plus B is going to be 8 squared equals 2R. Need to make sure I square the whole lot. So now I'm into my find it. Doing the maths. So 100 plus 64 equals 2 squared is 4, and that becomes R squared. So it's going to be 100 and, ooh, let's actually write that correct. So 164 equals 4R squared. So 164 over 4 equals R squared. So R squared equals 41. So on the side, yep, 41. So R is equal to square root 41. So now, there's my fit there. We're asked in a sentence, I need to answer it. The radius is square root 41 centimeters. And so that's my fixer. Last question, question 10. So now we have to find a one decimal place the distance between the centre of the circle. So first thing I'm going to draw in this diagram is distance between the two centres. So the centre down to that centre. What I need to do is set up a right angle triangle. So if I put a line parallel to the base tangent there, across here, that's going to hit here at 90 degrees. If the radius here is going to be 8 centimetres, the radius here is going to be 4 centimetres. So therefore I know the distance that's going to be left over there. So let's redraw this diagram just with our right angled triangle again. So for a triangle like that, we know that's the right angle there. We want to find this value here. We know the full length from there down to here was 8 centimetres. So the distance there is going to be 8 take 4, so it's going to be 4 centimetres. And this is going to be 15 centimetres. So on that there, I'm going to label it. So opposite the right angle is C. We've got A and we've got B. So now we're going to have A squared plus B squared equals C squared. So we've got A, which is 4 squared plus 15 squared equals X squared. 16 plus 225 equals X squared. So 241 equals X squared. X equals square root 241. So now we want to go to one decimal place. So let's just rewrite that. X equals 15.5 centimetres. Haven't quite finished. We need to write it as a sentence. The distance between the centres of the circles is 15.5 centimetres. So again here, we got our figure, we got our facts, we got our formula, we got our find it, and we've got over here our fix it. Thank you very much. That is the end of the Pythagorean revision sheet.